Now, the next thing what happened is that after some time, I think probably in 50s, people thought, okay, how long are we going to deal with these binary digits, right? So what they did is they actually wrote a program that can take some more English-like instruction and translate that into binary digits. So what they can do is they can write the program in a much easier format and then feed that into this translator program, and the translator program will translate that into binary program, and then you can take the binary program and ask the computer to run that, right? And so here's the process I'm showing. It's called as assembly. I don't know how they thought of, maybe they thought about manufacturing assembly, right? Maybe they thought like that. So they write their instructions in assembly code. It's a format. We'll come to what that format is. And then there's a translator program called assembler, and from the assembler you get binary code, and then finally you can take the binary code and ask the computer to run the binary code, right? So the same instructions, if you see, the one in the red is the assembly instruction, right? And you see that it uses words like LDA, ADD, SDA, HLT, right? So these are sort of mnemonic codes to the actual binary code. And for numbers, they used hexadecimal numbers. Okay, they're still not using decimal numbers. They're using hexadecimal numbers. But it says LDA 304. That means load data to the accumulator from the memory address 304. Then add to what is there in the accumulator the number 305, the address 305, right? Then STA is now store what is in the accumulator in the memory address 306, and HLT means halt the program. And you still need to know about memory addresses. You still have those data in the memory addresses, but your programming has become a little easier because instead of using zeros and ones, you're using 3-letter English characters and some hexadecimal numbers, right? And this helped the programmers a little bit. It did help the programmers a little bit. So, and assembly programming is not new. I've probably done it maybe 15 or 20 years back. I've done some programming in assembly. And usually at that time, we used to program in higher level languages, but there were parts of the program that needs to run really, really fast. And and we'll come to the higher level languages. When you write programs in higher level languages, you don't have control over how the binary code is generated. Okay, sometimes they may generate something more inefficient. Okay, instead of doing things in 2 steps, they may do it in 6 steps, and that means your program is not going to run fast. So then that time we used to write assembly programs, but then later in time, machines became really, really fast, and so what was slow 20 years back is not slow anymore, right? And therefore all of us forgot to think about assembly language. But assembly language is still taught in the colleges, and one of my friends, a professor, I asked him, why do you guys still teach assembly language in colleges? And he said an interesting thing. He said that, well, that forces people, that forces the college kids to understand how the computers work. Very interesting way to put it. So that's the only reason today, I would say, unless otherwise you are in some kind of control system field, in some fields where there's no, things need to run really fast, and the instructions that you need to provide is really, really small. So write it in assembly, right? But learning assembly language is, I feel like it will help you understand how things work inside the computer. And therefore, once you know that, you may write your programs in a much better way at a higher level language. Okay. Okay, now let's talk about high level languages. Okay, so a high level language is, people realize by this time that, it's possible to write something in one format and translate that and then convert that into binary instructions. Okay. So then people said that why stop at assembly language? Why not we create something that is much higher level, which uses decimal numbers and regular mathematical expressions, and also use some English like words, so that you can still, it could be a language that is human friendly, but at the same time you can instruct the computer in a mathematically precise way, right? Is it possible? And it is possible. So then came all sorts of higher level languages. Okay. Now the same instructions that we wrote before, let's see how it looks in high level languages. Okay. And I chose 4 languages: C, Java, JavaScript, and Python. And all of these languages are used by professionals today. That's kind of why I chose. But there are 700 or 800 languages that's used in this world. Okay, so 800 computer languages I'm talking about. But computer languages are not like our the human languages. Remember that. Okay, they all are very similar. So if you see the program that we wrote before in assembly and machine, now when we use higher level languages, see how easy it is, right? The first thing you'll see is they're all very similar, right? And you'll see these letters like A, B, and C. What has happened is that in high level languages, you don't have to worry about memory addresses, CPU registers, etc. Okay, you come up with names to to name a part of the memory address, so that name A, B, and C is came up with the programmer, right? And you can put whatever you want. You can put coffee, tea, and something else, right? And the moment you do that, the translator figures out what sort of memory address it should allocate, how much memory should it allocate, right? And in Java and C, if you see that we are saying int, so that means we are saying that hey, it's an integer. So the compiler knows, or the translator. Okay, the translators are called compilers or interpreters. We'll see that in the next classes. But the translator will kind of figure out all that thing behind the scenes. The programmer doesn't have to worry about those things, right? And if you see, you can use variables very similar to how we use variables in mathematics. Okay, that's why you see that a equals something, b equals something, and c equals a plus b, and the computer will behind the scenes do the calculation, right? And use expressions that is very similar to mathematical expressions. And then you use some English like words for simple controls like branching. If if one number is bigger than another number, then go and do something, right? So you have some English like words like if, for, while, etc. With that, you still can, your programs will be a little bit human readable or human understandable, but you can still precisely, mathematically precise instructions can be given to the computer. And then you have this translators which will translate this into real binary program, and you can run that. So the real reason why we have high level languages is that it's more about readability and maintainability. Okay, programmers are very expensive because they go and study a lot, and so paying programmers is a lot of money. And so if your program is not readable, then what happens is your program is useful only until the programmer is there. And even programmers, after a month, they will forget what they wrote, right? So the concern with high level languages is the language has to be very readable. It's easy to maintain the program. It's easy to maintain because programs live for long years, 20 years, right? At least in my company, there are programs which is 30-year old, yeah, right? So even after the original author is gone, other programmers can maintain these kind of programs. If you write something in binary, right, unless otherwise it's written in some paper, what it actually does, it's very hard to figure out what it does. But with the high level language, which it might be much easier. Even in high level languages, it's challenging, okay? But it's much easier that we can read a program and say, okay, this is what it's trying to do, right? And that's kind of the reason why these high level languages came into picture. Now, as new to programming, a lot of people will ask which language to learn first, which language will get me a job, right? Well, the world is very, very complex now, but I will promise you that if you can learn maybe 5, maybe 4 different sets of languages, then you're ready to do something useful. Okay. The reason is that for these languages they're tools, right? And can you say that, hey, in order to do carpentry, which one tool I need to learn, right? You got to learn some 5 or 6 tools. Okay, so it's very similar to that. You got to learn for 5 or 6 things. Okay, so that's about high level. So all these things I went through step by step just to give you an idea of why you should appreciate a higher level language, right? It's much better than those other types of languages which you saw. But you still need to, understand what's under the hood, and that's why I showed you all those things. So ultimately, okay, so let's say that you know languages, you can program. How does this programming business work, right? And it's a very interesting, programming is always a very interesting thing. You're always going to learn new things. You're always excited because, you're instructing or you're making the machine do something for you. Okay, that's a very exciting thing to do, and you can do that without breaking anything, without if you're building any other kind of mechanical machines, then there's a lot of noise and a lot of things, right? With programming, it's not like that. You can sit at home and you can write programs, and then you can make computers do some amazing things. So that's why it's interesting. So in the professional world, this is kind of how it works. You have you will have to first define what you want to do. Okay, and some of it is very easy, some of it is quite difficult, and some of it may take some time for you to define. So this is defining what programs to write, right? So because there are things that you can see, you'll see that a user is doing something repeatedly many times, right? Can we just write a program so that they don't have to do that, right? And in my classes, I'm just going to make sure that every time we give you an example program, that program will be useful for you in your personal life. That's kind of what I have disciplined to do in these classes, right? But defining what the user wants is one of the most difficult problems in this world. Okay, and usually we talk to the users, do some analysis, do some research, because sometimes user has a problem, but they won't tell you all of it. They won't tell you the full story, right? So you kind of figure all those things out, and that's called as defining what you want to write. So once you defined what you want to write, then you got to go through some design. Okay, for simple programs you don't have to design, you can just go type it, right? But for something very complex or something very big, you will have to go through some design session. You will probably draw some pictures, talk to people, and remember, nobody writes program on their own. It's a team that writes, right? So the team needs to understand, and the team will have different ideas on how to solve a problem. Okay, so defining what the problem is, and designing is finding a solution for it, right? So you will be doing that, and once you have the design, you will do develop. or development. And development is basically taking whatever you have in the design and formatting that in a computer language, and then translating that, running in a test computer and making sure that it is right. So you do that, and then there is a testing phase. Okay, and during this time, you really make sure that your program works correctly. It runs fast. It can handle a lot of load, the load that is expected. So all these things happen during the testing phase. Okay, and after you test, you actually try to ship your product to the user, right? And there are various ways in which you do it. You can probably put it in a server where users can download it. You can create a CD-ROM and then ship it to the user. There are so many ways in which you can after you're done with your programming, give that to the user. That's what that deploy means, right? And the important thing is that all of these things need to be done in a short time frame, because the cycle continues. What I mean by that is that as soon as you give this to the user may say, oh, by the way, I forgot about this, or oh, this works great. Can you also add few more, right? And so you go through the cycle again. You define, design, develop, test, and deploy, right? And so we call this, in today's world, we call this as iterative development. That means you go through iterations of producing software that is useful to the user. And sometimes the user will tell you that, do more to me, right? And this happens all the time in the software industry, because you're never, I mean, think about it. They wrote the Windows operating system, right? They started in somewhere in the 90s. And then they have these versions. What are these versions? Versions are nothing but you take the same software and then add more features to it. That's what these versions are. And so now we have Windows 10, and then you have all those service packs, and nowadays you see all the software updates that comes through. Even in your iPhone app, you have software updates, right? Because that's what we do. We start with something small that is usable, and then keep adding more and more and more to it, and ultimately, some software becomes very useful. And if you really see, all this software in the very beginning, they will not be that useful, but over time they becomes useful, and after some time they become really old, and then you go and write some new software, right? So that's kind of what your programming process is. So that's the end of this class. Let's go and recap. So we defined what is computer programming. We understood what happens under the hood. We have CPU, we have registers, we have control unit, arithmetic and logic unit, and input output devices, the hard disk, the external storage device, and memory, right? Then we try to understand what an operating system is. Basically, operating system is software that manages hardware, and so it's a layer of software that applications can use so that they can write software that is focused on the users. Then we learned about the binary number system, and we looked at how machine instructions looks like inside the computer. Then we went through the history of, well, machine instructions. Then later we had assembly instructions that could get translated into machine instructions. Then we know now that there are high level languages that is better than assembly language, where you just focus on regular mathematical expressions and use decimal numbers and use English like words to write instructions to the computer, and then it gets translated to binary instructions. And how do we start programming? We define, design, develop, test, and deploy. Okay. So with this, do go into the next class, which is where you will actually do programming to understand what programming is, right? And I'm going to use the Python language to teach you that. So until then, thank you for your time, and see you in the next class.